Today we are going to talk about higher order derivatives. Up until this point we have primarily just worked with this first line here, which is y prime or f prime of x or dy dx, which is we call the first derivative. Okay, and so these are some notations that we use. This is a 2 tick mark. For higher derivatives, okay, so a higher derivative like y, this is, we say y double prime, this is f double prime of x, and this is the second derivative of y with respect to x. We call this the second derivative. And the way that we find each one of these, it's very straightforward. Essentially, to find the second derivative, you take the derivative of the first derivative. And to find the third derivative, y triple prime, f triple prime of x, or the third derivative of y with respect to x, is to take the derivative of the derivative before, right? So if I'm looking for the fourth derivative, then that means I'm going to have to find the first three in order to get to the fourth, okay? So this one, then after the third derivative, we stop using tick marks, so we use a little 4 as a notation. So this is the fourth derivative of y, the fourth derivative of f, and then the fourth derivative of y with respect to x, and so forth and so on. Primarily in here, the most useful applications are we use the first and second derivatives primarily. I mean, we can use the third derivative, but primarily in here we're going to use the first and second. Okay, so some applications of the derivative. Now we've seen an example before of velocity where f prime, if f is the position function, then f prime can be considered the velocity function. Now we have f double prime is the acceleration function. Basically, the acceleration tells me how fast the velocity is changing, is what the acceleration function tells me. So the general rule of thumb, these are the ones that we use the most often. If s of t is a position function, then s prime of t is the velocity function. We just call it v of t. S double prime could be also called v prime, which is equal to the acceleration function. So these are different ways that we can say the same things. All right, so let's start out with an example of a position function. So I have s of t is 3t cubed minus 6t squared plus 4t plus 9. And so we're given that t is in seconds and s is in feet. Okay, so we're going to find the velocity function. Well, v of t is just s prime of t, so we're just going to find s prime of t. So we're going to use straight up power rule here. We don't even need the product rule or the quotient rule, which is nice. So we're back to our power rule. So we have 3 times 3, which is 9t to the 1 less power squared. So then I have minus 6 times 2, right? 12t, and then plus 4, the derivative of a constant is 0. So that's I've got my velocity function. Now, so if s is in feet, right, then v of t is in feet per second, right? Think in terms of slope. So the xy coordinate here of s would be seconds comma feet, and so slope is y over x, right? And that's essentially what v of t is the instantaneous slope at the point. And so it has units of y over x, so feet per second. Okay, so let's find the acceleration when t is 1. So a of t is equal to either s double prime of t or v of t, or v prime of t, I should say. So we're going to just take the derivative of this and get v prime. So a of t, or v prime, or s double prime is, so I'm just taking the derivative. To find the next derivative, I take the derivative of the previous derivative. 9 times 2 is 18, t, and then minus 12. So that's my a of t. If I want the acceleration when t is 1, then I have a of 1, which is 18 minus 12, so I get 6. Okay, so my velocity function was in seconds. This is s, right? Those are the units up here. And then my output was in feet per second, right? So that's velocity. So that means that my acceleration is going to have units of y over x. So it's actually feet per second, which we just say per second squared. Okay? So it's like we have this, feet per second divided by seconds, and we multiply each one by 1 over seconds. So we get this cancellation and we get feet per second squared. So this is in 6 feet per second squared. Acceleration is always in distance over time squared, and velocity is always distance over time. So it depends if, am I meters per minute, meters per mile? Well, no, that's not. It would be miles per feet. I did it again. Miles per hour, miles per second. So it would be distance over time, and then this is distance over time squared. All right. All right, so let's just find some second derivatives here. So in order to find f double prime, I need the intermediate f prime first. All right, so f prime of x is equal to, the derivative of 2 is 0, and I'm going to write this as, so I'm going to rewrite f here, 2 minus 2x to the minus 1. Remember, your rewriting is important because I can't take the derivative of x unless I can't use the power rule on it until it's sitting up, and I don't want to use the quotient rule on that, right? When I have a constant on top and just an x, that's just a simple power rule. I just need to rewrite it. So my f prime then, derivative of 2 is 0. The derivative of negative 2x to the minus 1 will be negative times negative 1, so I'm going to get positive 2x to the negative 2. And then my f double prime then is the derivative of that, which would be then negative 4x to the minus 3. If I wanted to write that without the negative exponent, which I highly recommend, especially if you are going to plug in a value. Like since this time I was just finding f double prime, this is perfectly acceptable. If I was doing f double prime of a number, it's better if you write it this way because you'll be more likely to put it in your calculator correctly. Okay, so we're going to do the same thing, this time finding f triple prime of x. If f is this, again, we need to find derivatives 1 and 2 before we can find the third one. So each one is just the derivative of the previous. F prime is, simple power rule, just a nice polynomial here, 4x cubed plus 6 times 3 is 18, x squared plus 4, right? The constant drops off. Derivative of a constant is always 0, so f double prime in between is 12x squared plus 18 times 2, which is 36x. This time the 4 drops off. And finally, f triple prime of x is 24x plus 36. So I found f triple prime. So higher order derivative is just the derivative of the derivative before. Now if I have to use the product rule or the quotient rule beforehand, then I probably want to simplify my derivative before I move on. I want to make it as simple as possible. All right, so let's do a little something else here. So let's use our derivative rules here. This time we don't know what h is. We just know that h is 3 times f of x plus g of x. And we find h prime at 2. And these are given to me. Okay? So this is like one of those lab questions where you're given a bunch of information, but you don't know the actual function. And so the first step is to just write out h prime. So let's remember all of our rules we use here. So when I have a constant times a function, the derivative, right, this is a scalar multiple, so the derivative of this term is just 3 times f prime of x. But I don't know what the derivative is, so I just call it f prime. And then the derivative of g is g prime. So h prime of 2 means I'm going to plug in 2 everywhere there's an x, right? So I have 3 times f prime of 2 plus g prime of 2. So now I have this table that I can drop things into. So h prime of 2 is equal to 3, f prime of 2 is equal to 2. So I have 3 times 2 plus g prime of 2. G prime of 2 is negative 4. And so I end up with 6 minus 4, which is 2. H prime of 2 is equal to 2.